Numpy array manipulation. Numpy manipulation is used to make certain changes in certain characteristics and properties of an array as and when needed. But before we learn to change the properties of an array, we need to understand and we need to be able to find out the properties by ourselves. For that, we study numpy.arrange. Arrange is another method to initialize a new array. Numpy.arrange is similar to numpy.transpose that we have done earlier, but there we gave the numbers of elements in a matrix. Here we give the step size of the matrix, start, stop, and the step size. Let us see with an example. X equals to np.arrange. So here start and step are two optional parameters where stop is the necessary parameter. If start parameter is not given, then it is considered to be 0, and if step parameter is not given, then it is considered to be 1. So just let's hop in. So here I am only giving the stop parameter. Let us see what we get. So we have got all the elements between 0 to 9. So here I have given the initial parameter to 0 and let me give it 5. So here the step size has been 4. 9 minus 5 is 4 and 13 minus 9 is 4. So the step size is 4 and the endpoint is 16. Why here I am getting 13 and not 16 is because if I add 4 to 13 it would go 17, which is greater than 16, hence 17 has not been included in the array. Okay. Now we know another way of making an array. But how can we find the shape of an array we just made? So we know what is x. To get the size of an array, we just need to write x.size or the array name and the size. I got 5. However, even if I define multiple dimensional arrays, brackets you should never forget. Let us see what x is. It's a huge array, and if I write x.size, it gives me 56 because 7 8 is 56. But what if there is an array for which I need to know the rows and columns and not the size of that array? Here I can use a command called array.shape. So I got the shape of the array. X.shape gives us the dimensional analysis of that array. Reshape method. If you want to change the dimension of the array, reshape is the useful method to use. However, the product of your new dimension should be equal to the product of existing dimension. Or as we can see here, the number of element in the new array should be equal to the number of element in existing array. Imported the numpy. So here I have created a new array. This array is 4 into 3 dimensional array with all the elements as ones in it. So now let me print this array first. Okay, and a new. So in this statement, I have given a as the array and the new shape is 3, 4. So let's print the new array. So you can see the change of shape. Here the first row is 3 times 1. Here the first row is 4 times 1. So the shape has clearly changed. However, if I give the new shape to be 3, 3, the product of whose is not equal to number of elements of existing array, this should show an error. So here as we talk, this will show an error. So we need to be careful with the size of the array whenever we are reshaping the new array. Transpose. This method is same as the mathematical transpose on a matrix. It returns a matrix after interchanging each rows and the corresponding column. So you can clearly see how transpose work if you don't have much idea, but this is technically elementary school mathematics. Interestingly, this method has two syntaxes of writing it. One can be numpy.transpose, and then you need to pass an array as an argument. Or you can simply write array.t. Now let us hop on to codes and we'll try the syntax. So here I have created my array. Let us get it printed. Now let us call the transpose method. So here clearly you can see that this array has been transposed. Now let us try the another syntax that we have seen, that is array.t. Simple. This short syntax can be very much useful whenever we deal with long equations or huge calculations with numpy arrays. Insert. This method is used to insert an element or a row or a column in already existing numpy array. The first attribute is an input array, which is denoted as ARR. The second attribute is the index before which the insertion has to be done, which is denoted by obj or object. And the third attribute is the values, which is the element to be inserted. And the fourth attribute is axis, the axis along which the insertion has to be done. It refers to ith dimension in which insertion has to be done. Let us see the relation between object and axis and how it helps us position the insertion or deletion of elements. These two parameters are used to locate the rows or column that is to be operated upon. Now axis 0 for a 2D array would refer to rows, while axis 1 in 2D array would refers to column. And for possibilities of 3D array, there would be more axis. Like 4D array, there will be axis equal to 3 and so on. We can better understand this with the help of codes. So I have created the numpy array that I want to use over here. Let us get it printed. So this is the same array that I have illustrated in the slide. Okay, so here I have written the insert method on the array A. The values are 999 and the axis is 0, which actually tells that I'm inserting a row. If the axis would have been 1, then the insertion would have been in the column instead of rows. And the object or the index is 1. That means the insertion would be just above the index 1. There will be insertion of 999 on the index 1. 456 will move to index 2 and 789 will move to index 3. Let us employ this and look at the results ourselves. So just as I predicted, 999 has taken the index 1 and the rest have moved downwards. So here I have written the insert method, and this time the axis is 1. That means there's an insertion of a column instead of a row. And the index that I have provided is 2. That means 000 will be taking the index 2 of this array and 369 will move to index 3. So let me print B. Yep. So here you can see how 000 has replaced 369 and there has been an insertion. If you don't write the axis along which to insert, then the input array is flattened. Let us try that. So here I have not given the axis parameter and here I get a flattened array. So we have done insert. Now let us come to delete. When you want to delete a row or column or any element of an array, one can use this method. So again, the first attribute is the input array. The second attribute is the object or index before which deletion is to be made. And the third attribute is access, whose working we have already understood in last slides. So let us hop on to codes. I will be deleting the elements from the array B that I had already created and have printed over here, np.delete. Hence, the input array is B, the access is 1, that means there's a deletion of a column and the column is at the second index. So if you guessed it right, yeah, deleted the zeros that I had already inserted in the array B. So similar to insertion, if you don't write the access, input array is flattened. Let's see. So here only the third element has been deleted and rest all are there, but as a flattened array, of course. The concatenate method. As the name suggests, it is used to link multiple arrays to form one array. Here there is an illustration of how this works in NumPy. There can be two types of concatenation in a 2D array. One can be concatenation along rows and the another can be concatenated along columns. The syntax of NumPy concatenate is as follows. First, we write the method name concatenate and then we provide all the arrays that are to be concatenate in a bracket, and then we provide the access along which the concatenation has to be done. We can better understand this using codes. So here I've created both my arrays to be concatenated. So I can write my concatenate method without mentioning the access, and the access will be taken to be 0 by default. So here it is, and I can also mention the access to be 0 and I will get the same result. Here it is. This time I have given the access to be 1. So it will be connected column wise. So I've created a new array C which consists of all ones. The dimensions are 2 into 2. So I've written the concatenate method to concatenate 3 different NumPy arrays. And here it is. Thank you for watching the video. If this video has helped you, please give a thumbs up. And if you're into Python, algorithm, machine learning, neural network, and AI, this page is for you. Please subscribe the page thinkNow as making better content every day.